All right, today we're going to look at what's called direct variation. So three things we're going to look at is the equation, table, and graph. So in order to be in direct variation, it has to be an equation in the form of y equals kx. K will be a number. So most time we see equations in the form of y equals. Sometimes there can be occasionally a plus and a minus after the x. So if there's not a plus or a minus, we do not count that. So no plus or minus. So no plus or minuses added at the end. Okay. Then our table is going to be in the form of y over x, and we want to have a consistent number all the way down between our y's and our x's. So if I take 2 over 1, and then in this case, I'm going to simplify it, it's going to turn into 2. And I'm going to take 4 over 2, which simplifies to 2. And then 6 over 3, which simplifies to 2. So for a table to have direct variation, your y over x, or as known as your k, has to be the same number all the way down in your table. For your graph, it has to go through the origin, which is the center of the graph at 0, 0. And it also must be a straight line. And it doesn't matter if it goes this direction or if it turns the other direction, but it has to go through the middle of the graph. So let's look at some examples. So number 1, I want to know if they're direct variation or not. So number 1, we have y equals 2x plus 1. This would be no. It's not direct variation. No, because it has the plus 1 at the end. Then you can't have any adding or subtracting at the end. Number 2, y equals 6x. This would be a yes, because there is no plus or minus at the end. Number 3, so remember with the table, it's y over x. So I've got to take 8 over 2 and simplify it, which is 4. And then 16 over 4 is 4. And 24 over 6 is 4. So they all equal 4. So this would be yes. Number 5, same thing. We're going to take and we're going to try see all of them will equal the same. So 5 over 1 is 5. My 10 over 2 is 5. 15 over 4 is not 5.